Chapter 4, Lesson 3, Graphing Proportional Relationships. In our standard 8EE5, you can see, just like the title of our lesson, we have graph proportional relationships. So this standard is touched completely on in this lesson. You can see we're going to be working a lot with this equation, if you will, y equals mx plus b. And as we've talked about before, there's that m that is slope. Our vocabulary is slope. The skill is graphing proportional relationships. So let's talk about proportional relationships. Interestingly enough, they're going to define it as a direct variation. I myself would use what I call graphic notes again, where I'd circle up direct variation, and I'd draw a little arrow down here to proportional. These two words are interchangeable. They are the same, so if you need to make that note to yourself, proportional is the same as a direct variation, where again, here's that equation you can see, and then we're talking about m being our slope, or being the constant of proportionality. Big word, again, just talking about something interchangeable, because we can talk about m also being our slope. So when we see these words, we have two different ways to phrase it. So you're going to hear me say them both so you're familiar with them. So if they ask if an equation or a graph is proportional, they're asking the same thing if it's a direct variation, whether it's on homework or quiz or test, IXL or standardized testing. They may use either of those words. In this instance, they may ask for what is the slope, what is m. They also may say, what is m? What is the constant of proportionality? Remember, when we look at this today, we're going to talk about this, where the graph is going to be this, y equals mx. And then when we talk about that, that's a graph who has a slope of m, and then it passes through the origin. Today, when we talk about if something is proportional, if it is a direct variation, there are two things. One, it needs to be a straight line. So it's got to be a line, right there it says that. And then it has to go through the origin. So two things. It needs to be a straight line. First thing is a straight line, or just line. Everyone say line. Did you say line? Make sure people in class say line. Say line. And the next one, number two, it's got to go through the origin. Say origin. Did you? Here's the last chance. Say origin. Origin, if you need the reminder, that is the ordered pair 0, 0, where we begin graphing on a coordinate plane. Two things needed to be in order for it to be a direct variation. When we talk about it here, we've got the cost in y dollars. Always kind of nice to know what our variables stand for. So y is going to stand for dollars. And then that's where we're going to find out that our x stands for video games or games. And they give us a lovely equation right there of y equals 4x. So we're going to use this guy, and it says to graph the equation and interpret the slope. A couple ways you could do that. You could make a table quick, where you could just tell me, well, if you rented 0 video games, 0 for x, what's 0 times 4? Well, that's just 0 for your y. What if you rented 1 video game? That would give you $4. If you rented 2 video games, how much would it cost? $8. So that's a quick little table you could make, mental math you could do. You also know that today it's going to be a proportional relationship, since we've got this 0, 0. If you rent no video games, you spend no money. So then you could put a nice, lovely little dot there on 0, 0. And then from there, you can graph those points, 1, 4, 2, 8. Another way you can graph it, we have our formula, or rather the equation y equals mx, where we wrote in a previous chapter tons of time that m equaled slope. So if m equals slope, and we talked about slope as being the rise over run, if your slope, your m is 4, what's that as a fraction? That would be 4 over 1, which means from each of the points, you need to go up 4 over 1. So you could use the graph as well to go up 1, 2, 3, 4, and over 1. Then from this point here, you can then go up 1, 2, 3, 4, and over 1 again. You can use slope, which we will start doing in the next lesson, and we're going to use a lot in Chapter 6. You can use a table because they didn't tell you how to graph it. You get your choice. Please remember then when you connect them, don't just try to freehand it. You really, really want to be doing and getting into the habit of using a straight edge. Remember, in class, I provided some rulers. If you need a ruler, let me know. Otherwise, catch any kind of straight edge, the edge of your textbook, the edge of a notebook, folders, anything like that, and then connect them. And make sure that your line is not dotted. That's just how mine with the program comes. But do make sure there are arrows on both ends. Now, we have successfully graphed the equation. Now it says to interpret the slope. Well, we already down here said the slope was 4. So if the slope is 4, tell me about it. For what? 4 Toblerones per day? 4 crying fits from my 3-year-old every minute? What, is it 4 cookies an hour? What do we have? What we need is, when it says interpret, you need 2 labels. A hint here as well is to go back, and we talked about rise over run. So what is the rise variable? What is the rise variable? Well, that's the y, and we look at the y. What was your label for the y? Dollars. So that's going to be first, whether you want to put the label dollars out front or the word. And then we talk about next, it's rise over run. What is your run? What's the label down on the x values? Well, if it doesn't say on the graph, you can go up in the book again, or up in the problem where it says video games was our x. So then that's $4 per game or per video game. Tell me what that 4 stands for when it says to interpret the slope. $4 per video game rented. The daily wage of a factory worker is Y, so that's how much money they make. Again, highlight it, circle it up if you want to, or don't. Is proportional to the number of parts X assembled in a day. Normally, they would give you an equation. A worker who assembles 250 parts in a day earns $75. Just write an equation. So we're going to start with our y equals mx. That's what we use today because, again, go back to the problem. Is it a direct variation? Is it proportional? If he puts 0 parts together, does he get paid? No. So it goes through the point 0, 0, and it has a constant wage, constant rate of pay. And then that's what we're going to have to try to find. So writing the equation, what we're looking at here is y stood for dollars. So I see a 75 for the dollars equals, I don't know what his daily wage is, what that constant of proportionality is, but I do know the x was 250 parts. So go ahead and grab a calculator, solve for m by dividing both sides by 250. And then you get down to 0.3 equals m, which is great, but that doesn't answer the question. It said to write an equation. Go back. It was y equals mx right here. So plug on in our m value of 3. So 3/10, plug that on in. And then x. If you're worried about losing that decimal, make sure you make it obnoxious or evident clearly. That's writing an equation. Now, we can use that equation when it says how much does a worker earn who assembles 300 parts per day. You might already know what to do when we talk about 300 parts, but what we're going to do is we're going to use that in this equation. You might say, Mr. Wallace, don't we just multiply? You're right, but let me show it to you again. The parts, since we're talking about parts, that's the x value. So in the equation, y equals 0.3x, 3/10 x. We're going to put 0 and 3/10 times our x value, which is 300 parts. Grab a calculator, mental math, multiply that on out, and we see that y equals 90. Now remember, we're not told how long this 300 parts took to make. So don't think to yourself that a person only made $90 in one day working. No. This is just the context of the problem. He made $90 for 30 parts together. One of my wife's relatives worked, or at least did work, at a car factory where he put things together on an assembly line. So I could ask him, what his job was and how many parts put together, because maybe in this case we're trying to talk about a fair rate. wage and making money, it's probably something that's really simple and quick, and you can put 300 parts together in like an hour or maybe 2 hours, or maybe 3. Even that, 3 hours, it's still a pretty good wage. Remember, we're doing this because we're talking about our standard where we want to graph proportional relationships. Now, again, you can see down here, we're talking about interpreting the unit rate of a proportional graph. We're talking about interpreting the slope. So we're going to be looking a lot at slope, the unit rate, and proportional relationships. You have a word problem just like this on your assignment, but it deals with cars or kayaks or something like that. But here we're talking about a track event. The distance y in meters, so always good to know what some of our variables stand for. Traveled by student A is represented by this equation, y equals 7x. The graph, that'd be this guy right over here, shows the distance traveled by student B. Which student is faster? So again, there's a couple of different ways we can do this. Down here below, you can see part B says to graph the equation, so you could jump to that right away. We could also just look at our formula. We're going to use our proportional relationship equation where y equals mx. Where again, remind yourself that we talked about the letter M stands for our slope. So what is the slope in student A? Student A has a slope of 7. Great. Over here on student B, we're going to find the slope for student B, which we talked about in the previous lesson. M equals slope equaled rise over run. So you can pick any 2 points you want to. I see a point way up here, but I'm going to ignore that guy. I'm going to use these two here, where the origin is, and this guy. Notice again, be very careful when we talk about rising. How much up did we go? We're not concerned about how many blue lines we went up. We want to know the value. We went from 0 all the way up. So don't tell me that it is 6 lines. Tell me that we went up 24. And then how much did we run? How much did we go over to get to there? Again, 3 lines, but make sure the lines down here are going by ones, which they are. So student B then has a slope of 8. Interpret the slope. It doesn't say that, but when it says 8, what is that? 8 headaches a day? 8 pages per hour that you're reading? In the context of this was 8 meters per, and then the x, these ones stood down here for our seconds. You can see that here. So 8 meters per second, which means interpret our slope of 7 up here. Well, that was 7 meters. If you want to spell out the word meters instead of just the letter M, you can do that. Per second. Who's running faster? You are correct. That would be a student B. If you had to justify it, you could talk about their slope as running faster. Part B, not student B. Part B, it says graph the equation for student A. Compare the steepness of the graphs. What does this tell you? If you hear the gun go off and don't move in the track meet, how far have you gone? If you don't move, do you move at all? No. That gives you 0. So that means our first point is here at 0, 0. Now, we already talked about our slope for this student is 7. We talked about that right up here. 7, or 7 over 1, where again, that means we go up 7 over 1. So if I adjust this just slightly here, try to slide this guy out of the way so you can see it. Now, we're just going to go up, and we're going to do the best we can. Go up 7 and over 1, so that means we're going to kind of put it right there, just a little bit below that. I'm off a little bit, but it'll be all right. Then we're going to go over 2, right? We could go from here. We could go up 7 over 1. That's kind of tricky to do. So after 2 seconds, what's 2 times 7? That's 14, so that's right about there. And then again, after 3, we're at 21. Boom. Whoops, that's off a little bit, but we can slide that on over. At 21. Yep. And then after 4 seconds, you're at 28, which comes out to be, ooh, that's a little high on my technology. Perfectly right there. So again, now you can graph it. Don't just grab that straight edge, do the best you can to graph a straight line through all of those points with an arrow, preferably on both sides out of habit. And now you can talk about compare the steepness of the graph. Which one is steeper? The colorful one representing student A, or the black line one for student B? The steepness of the graphs, student B is steeper. Student B has a higher slope. Student B's constant of proportionality is higher. The slope is bigger. Great explanations. Great way to say that. Notice again, as we talk about these, they are direct variations. They are proportional because they are, one, a straight line, and two, through the origin. If I were to give you a graph like this, notice, yeah, that's a great straight line, but does it go through the origin? No. So that's where we talk about this is not proportional because it does not go through the origin. That's what we're looking at when we talk about a graph. So when you view from a graph, it needs to be those two things. Everybody say two? Did you say two? In class we said two. It had to be a straight line. Everyone say line. And it had to go through the origin. Say origin. Line and origin is what it has to do. So if they are in a proportional relationship, if they vary directly, there are two things. They're going to be a straight line, and they're going to go through the origin. So let's look. First off, straight line. Do all the x's change by the same amount? They're all up plus 5. Good. Now, with the table, let me be very careful. When we look at our y values, in the y values, are they increasing by the same amount? Meaning from 1 to 2, we're going up 1. From 2 to 3, we're going up 1. Did all of these values down here, did they all change the same? Yes. So then that means we have a line. Does it go through the origin? Well, do you see the point 0, 0 in the table? If not, then go back. What would the previous point be going backwards at 15, then 10, then 5, then 0? 3, 2, 1, the previous point would be 0. So it is a proportional relationship. It is a direct variation. Explain your reasoning. It's a straight line, or just a line, you could say, through the origin. Now, the instructions don't say that here, and I'll change that for our notes for future reference, but they will say, now, write an equation. Okay? Let's write an equation. Y equals mx. Today, this is the equation. When you need to write an equation, this is what we use. Yay, tiny smiley faces. Now, m, as we wrote about before, m stands for your slope. M equals slope, which we've said is rise over run, but that's not going to work in this case. So when we talk about m equals slope, we're going to need to do the change in y over the change in x, which is still your rise, how much the y changes, over the run. Just not saying it that way. So go back. What was the change in your y values each time? 1. Very good. And then what was your change in your x values each time up there in the table? 5. Great. That is your m. That is your slope. That is your constant of proportionality. All words for it. You just plug that into the equation. So your final answer, y equals 1/5 x. And you're done. You have to write an equation like you'll do on the first couple of problems in your assignment. That's what you're looking at. Again, we want to be able to do this because it's right there in the I can. It's right here in the skills. We talk about slope and proportional relationship. Today you're going to write and graph proportional relationships.